Hi everyone, I'm Andrew Redden with the Join program here at Timescale, and today we're going to discuss the differences between synchronous and asynchronous replication and what considerations you should make when choosing the appropriate method for your use case. In Timescale, there are two primary types of replication available, synchronous and asynchronous. Both serve to keep your data consistent across multiple instances, but they're designed to address different priorities in database management. Synchronous replication is all about guaranteeing data consistency. It ensures that every transaction on the primary database is fully written to the replica before it's marked as complete. This approach is ideal for scenarios where immediate consistency is essential, like financial systems or other mission-critical applications. Asynchronous replication, on the other hand, prioritizes performance and speed. Changes on the primary are committed right away, with updates sent to replicas in the background. This means that there might be a small delay between the primary and replicas, but it enables faster transaction processing, making it well suited for high-traffic applications that can tolerate minor data lag. Each replication type has its own advantages and trade-offs, and choosing the right one depends on your specific needs for consistency, performance, and failover readiness. Let's dive deeper into each type and explore their unique characteristics. Synchronous replication in Timescale is all about data consistency and failover safety. When a transaction is committed on the primary database, it won't be marked as complete until it has been fully written to the designated synchronous replicas. This ensures that every change is captured and in sync across all copies at the moment of transaction completion. One significant benefit of synchronous replication is that it provides immediate failover. If the primary database goes down, the synchronous replicas contain the latest confirmed data, which can be crucial for applications where even a small amount of data loss is unacceptable. However, this method can add latency because each transaction waits for confirmation from the replicas before it completes. Because of this, synchronous replication is generally recommended for mission-critical use cases where data consistency is essential, even if it slightly impacts performance. One important thing to note about synchronous replication is that it's only available in a multi-HA setup, in which there is more than one replica. Asynchronous replication, on the other hand, focuses on maximizing performance and reducing latency. In this setup, changes on the primary database are committed right away, without waiting for acknowledgement from the replicas. This means that transactions complete more quickly, which can be especially beneficial for high traffic or performance-sensitive applications. Since updates are sent to replicas in the background, asynchronous replication offers what we call eventual consistency. This means that there's a small lag between the primary and replicas, which may result in temporary inconsistencies if replicas are accessed immediately after a transaction on the primary. However, a key trade-off here is the risk of data loss in failover scenarios. If the primary goes down before recent changes reach the replicas, those transactions might be lost. Asynchronous replication is generally well suited for applications that prioritize performance and can tolerate minor data delays, like analytics workloads or read-heavy applications where immediate consistency isn't as critical. Replication configurations can be tailored to fit different needs, from development environments to mission-critical applications. For non-production environments, such as development and testing, it's typical to have no replicas. This setup is ideal for developer environments where data redundancy isn't necessary, allowing for simplicity and reduced costs. For production applications that require high availability, a common setup is to have a single asynchronous replica in a different AWS availability zone than the primary database. This setup provides high availability with a focus on cost efficiency, ensuring minimal downtime without incurring the costs of additional replicas. For applications where the highest level of availability is essential, there are two replication modes available. The first is high performance mode, which uses two asynchronous replicas and is designed to provide the highest availability across two AZs while allowing queries on an HA system. This mode is ideal for applications where uptime is absolutely critical but can tolerate slight delays in consistency. The other mode is the high data integrity mode, which includes one synchronous replica and one asynchronous replica. With this setup, the synchronous replica is always fully up to date with the primary, ensuring no data loss. This mode is best for applications that can tolerate no data loss, providing a blend of high availability and data safety. Each of these configurations allows you to balance availability, performance, and cost based on the specific needs of your application. This concludes our video on the differences between synchronous and asynchronous replication. Thank you so much for listening, and I look forward to seeing you in the next video.